Hello, and today we are going to cover section 7.1, rational expressions. A rational expression is just a fancy way to say fraction. Okay? In this case, though, the top of the fraction and the bottom of the fraction, or the numerator and denominators, are going to be expressions or polynomials. So there's going to be numbers and variables. But we could never have 0 in the bottom of a fraction before, and we still can't have 0 in the bottom of the fraction. So in the numerator, you can have any number up there, any number, any variable. But in the denominator, we cannot have 0. We will deal with fractions that have expressions. The bottom of the fraction can't be 0, and when that happens, we say that the expression is undefined. To determine when a rational expression is undefined, we're going to take the denominator, or the bottom part of the fraction, and we're going to make that expression equal to 0. We're going to solve that equation, and then whatever the answer to that equation is what the number of x can't be, or the number of the variable can't be. So let's try this. Determine when the rational expression is undefined. Okay, so we're just going to go to the denominator, which is 3x, and we're going to set it equal to 0. When I solve this equation, I get that x is equal to 0. Okay, so we know that actually x cannot be equal to 0, and that's our answer. So this expression is undefined when x is 0. Next example. Okay, the bottom of our fraction, or our denominator, is 3x minus 1. I'm going to set that equal to 0. And now I'm going to solve. So 3x is equal to 1. X is equal to 1/3. So when x is equal to 1/3, it means that the whole equation, or the whole fraction, has a 0 on the bottom. And we can't have that. So x cannot equal 1/3 is our actual answer. Determine when the rational expression is undefined. I'm going to take the bottom of the fraction, which is x minus 2, and set it equal to 0. When I solve that, I get that x equals 2. So what that means is when I plug 2 in for x, I get 0 on the bottom of the fraction, which is not allowed. So my actual answer is that x cannot equal 2. Determine when the rational expression is undefined. Our rational expression is x squared minus 5x minus 14 equals 0. Well, remember we learned in chapter 6 that whenever we have a squared term, what we have is a quadratic function. And in order to solve that for 0, we have to factor. So what two numbers multiply to negative 14 but add to negative 5? So multiply to negative 14 but add to negative 5. It's going to be x minus 7, x plus 2. Negative 7 times 2 is negative 14. Negative 7 plus 2 is negative 5. So now I have my two expressions that I can set equal to 0. X minus 7 equals 0. X plus 2 equals 0. When I solve this one, I get that x equals 7. When I solve this one, I get that x equals negative 2. So my actual answer is that x cannot be equal to 7 or negative 2. Because if I plug 7 or negative 2 into that denominator, I'm going to get 0 on the bottom of my fraction. Evaluating rational expressions. When we evaluate, we're substituting a number for a variable. Our answer will be numerical. Evaluate the expression for z equals negative 1. The easiest way to do these is to rewrite your expression and put parentheses wherever the variable is. Okay, now in the parentheses, I'm going to put what they told me to substitute for. So I'm going to put a -1 and a -1. Now, if you plug it in your calculator exactly how you see it, it will come out the right way. Now, when we do these, we have to pretend like there are big parentheses around the numerator and the denominators. Okay? So what I have on the top is -2 plus 7. -2 plus 7 is a +5. What I have on the bottom is -1 squared. -1 squared is 1. 1 minus 36 is -35. Now I'm going to reduce that fraction, and I'm going to get -1 over 7 as my answer. Writing rational expressions in lowest terms. Basically, what we're doing is we're reducing fractions. Okay? So the first example I have here, I don't have any variables, I just have a fraction, but it's not in lowest terms. Okay? 15 and 40 have a GCF. They have a GCF of 5. So if I divide the top and the bottom of that by 5, I'm left with 3 over 8. Now that fraction is in lowest terms. Okay? 15x to the 4th and 5x. They have a GCF of 5x. So I'm going to divide the top and the bottom by 5x. So what I'm left with on the top is 3x to the 3rd, and what I'm left with on the bottom is 1. So 3x to the 3rd is my answer. Factoring to put rational expressions in lowest terms. Okay? So we always want to look for GCFs when we are working with rational expressions. So I have 8x plus 24, and I have 10x plus 30. So first I'm going to look and see if 8x and 24 have a GCF. They do. It's 8. So I take that out, and I'm left with x plus 3. Then I'm going to look and see, do 10x and 30 have a GCF? They do. It's 10. And I'm left with x plus 3. Now, because x plus 3 and x plus 3 are the same thing, I get to cross them out. They're in the parentheses. They are the same factor. And I'm left with 8 over 10. But that's not in lowest terms yet, because they can both be reduced by 2. So 4 over 5 is the answer to this one. Factoring to put rational expressions in lowest terms. Okay. So we want to look at the top and the bottom and see if there's a GCF. Is there a GCF between 3y squared and 6y? There is. It's 3y. And when I factor out that 3y, I'm left with y minus 2. Okay. When I factor the bottom, I want to find two numbers that multiply to -2 and add to -1. So it's going to be y minus 2 and y plus 1. These are the same factor, so I get to cross them off. 3y over y plus 1 is my answer. But what is our restriction? What can't y be? Y plus 1 equals 0. I did that because here's my numerator or my denominator, and it can't equal 0. So y equals -1. Okay, so the final answer for this one 3y over y plus 1, y cannot equal negative 1.